Hey, everybody, and welcome back to the final fun and exciting geometry class. Congratulations, you made it. We are at lesson 7.4. This is it. All right, so page is 288. I know you're excited. I'm excited. I'm done recording these lessons, so we'll be excited together, okay? So let's go ahead and finish this out strong and do our best to learn this information. The name of the chapter here, the name of the lesson here is Interpolation. I'm like, ooh, sounds tough. Sounds mystical. I don't know what it sounds. But I, we don't use it anymore because again they're talking about charts and different things like that. So we use calculators to get exact answers. Um, but here's the thing: there's so much more in this lesson than just interpolation. All right, there's trig identities and there's trig equations and there's all kinds of different things. So we're going to do the lesson, but I'm going to skip over the interpolation part. So let's jump into it. All right, so look down here, and we are going to be doing the trig identities to start. What is a trig identity? Well, because trig functions use ratios, right? We've talked about that. There are multiple ways of saying the same thing. The example here that I've listed is the sine of A equals the cosine of 90 minus A. That's the same thing. Again, there's an equal sign, right? So this is equal to this. This is like saying 5 equals 5. But it doesn't look like 5 equals 5. Well, it doesn't have to look like it because 4 plus 1 equals 3 plus 2, right? Those are equivalent. Those are equal. So it's the same thing here. Both of these are going to equal the same thing, but it's two different ways of going about it. I'm going to show you something, and I don't want you to, like, I don't know, jump off a bridge or something, okay? So here's what I'm going to show you. I am going to show you a little peek into pre-calculus, okay? I'm going to show you the front cover of the calculus book. Now, this is the inside front cover. Cofunction identities. Look, sine, and this is just using what's called the theta instead of using the a. So don't get scared about that. Theta is just a different way of saying a. Okay. So cofunction identities, product of sum identities, Pythagorean identities, double angle identities, quotient identities, half angle identities, sum and difference identities, negative angle identities. Here's the point I'm trying to make. You will be using these identities, okay? So what we're doing is important. So don't think, oh, it's no big deal. It's just some blah, blah, blah. No, no, no. What I'm teaching you right now is going to come back. You do them a little bit in Algebra 2, and you do them a whole lot in Pre-Calc. So work hard here and try to figure this stuff out. All right, so watch this. Sine of A equals the cosine of 90 minus A. So let's go ahead and put a triangle up here real quick. And I want to show you something. Kind of, we'll use a calculator and we'll do some other things with it. So if this is A, and if this is B, and this is C, if we take the sine of A, I don't know what A is. Let's just throw a random number at A. So let's say that A is, in this case, we'll make A 30 degrees, okay? So if we take 30 degrees, here's what I want to do. I want to solve this. So the sine of A, which is 30 degrees, so let's write sine of 30 degrees equals, and that's going to be this side, right? That's what we're doing over here. So let's go to the calculator, and let's type in sine of 30 degrees, and just hit equals. And that equals 1/2 or 0.5, okay? So let's put 0.5 right there. So that's sine A. So that's this side of the equal sign is going to be 0.5. Now what we want to do is we want to prove that this is the same thing over here. So now we need cosine of what? 90 minus A. So this is kind of the trick, and I'm going to show you how this all works. So this is our 90, right? And this is our 90 minus A. What's A? It's 30. So if we say 90 minus 30, that's going to give us 60. Watch what else what that does right here. That tells us what B is as well. B is 60 degrees. 60 plus 30 is 90. 90 plus 90 is 180. So if we take this cosine, let me change colors here. I'll do it right over here. So cosine of 90 minus 30. What's 90 minus 30? Cosine of 60. So if we take the cosine of 60, it should give us this 0.5. Now, if you're looking at this, what you should be thinking is, look, okay, so the sine of A is equal to the cosine of B, and you'd be exactly right, okay? Because in this formula right here, when you say cosine of 90 minus A, you could also say cosine of B, because the cosine of B equals 90 minus A every time. It has to. You can put whatever numbers you want in there, and B will always equal 90 minus A. So you could say the same. You could say the same exact thing either way. Let's solve it like this: cosine of 60. So let's go to the calculator and let's put in our cosine of 60. So now we're going to hit this cosine 60 equals, there's our 1/2, 0.5. So 0.5 equals 0.5. We are correct. This is what's called an identity. So sine of A always equals the cosine of 90 minus A. Let's jump back over here to this this page that I had up here, and I can show you right here it's cofunction identities. So if we have the sine of theta equals cosine of 90 minus theta, there it is. That's what's called an identity. Okay, so an identity is something that is always true. It's like 5 equals 5. What you'll find out is that as we get into trig and as we get into pre-calculus, we're going to need those identities to solve equations and solve all kinds of other things that we get into in those classes. All right, let's head back over here and let's finish up this lesson. Here's another identity. So let's look at it. In your book, this is on page 289, okay? Exercise 7.4, the first one I just solved for you. Here's the second one. Tangent of A equals sine of A over cosine of A. Now, this one's kind of interesting too. We don't even need the triangle to do this one. Let's do this one using SOHCAHTOA. So using SOHCAHTOA, what does tangent equal? Tangent equals opposite over adjacent. Okay? And now we say that equals, what does sine equal with SOHCAHTOA? Opposite over hypotenuse. Over, okay, so that's over cosine. What does cosine equal? Adjacent over hypotenuse, okay? Let's leave this side alone for right now and let's solve this side. You say, how do we solve that? It's just a division problem, right? So how do you divide fractions? You set it up, opposite over hypotenuse divided by adjacent over hypotenuse. Okay. Now, what's our rules when we're multiplying fractions? Yep, we invert the second one, so we flip that one upside down. You should remember this from fractions, and then we change this to multiply. So we have opposite over hypotenuse times the hypotenuse over the adjacent. These ones cancel out, and I'm left with opposite over adjacent. And I have the same thing here, opposite over adjacent. And so what you see is that this is true. The tangent of A always equals the sine of A over the cosine of A. Again, this is super, super important as you're getting into the next level of math. So make sure that you're trying to take this all in. I know I'm kind of overloading your brains right now, but it's a lot of stuff right here, but it's a lot of good stuff that you'll be using in the future. All right, last concept for this lesson and the last concept for the year. Here it is. How do I find my missing pieces of a triangle using sine, cosine, and tangent? So here's what I have, and this is going down in your exercises 7.4. This is number 6. I have BC equals 18, so this one equals 18, and then AC equals 24. Okay. Now, up until now, we've always used, to solve this, we've always used Pythagorean's theorem, right? And we could do it. So we could say a squared plus b squared equals c squared. It's fine. But we have a ratio. Now, if I want to know, I can actually figure out all of the parts. So in other words, let's kind of scroll down here and let's do, so we need to know what A equals. That's an angle. We need to know what B equals. C, we know that C is 90 already, right? So that one's easy. And we already know AC and BC. So AC and BC. So AC is 24 and BC is 18. Okay, so we've got some parts already down. So what else do we need? We need AB. Okay, so we need AB equals, and then we need these different angles right here. So we've got some things that we need. So let's go here and let's go back to this and let's think about this. Okay, we're not using Pythagorean's theorem. We are going to use trigonometric ratios. Well, a ratio means we have a fraction, right? So if we can find A by figuring out what is our fraction between these. So if I use A for my reference angle, I have the opposite and the adjacent. Which one, sine, cosine, or tangent, uses opposite and adjacent? You remember? Got it, it's tangent. So we have opposite over adjacent. So we can find the A by saying the tangent of A equals opposite over adjacent. What's our opposite? 18. What's our adjacent? 24. All we have to do now is plug that into our calculator, and that's going to tell us what A equals. But remember, from a couple lessons ago, we are looking for the angle. In other words, we have the ratio, but we need the angle. Do you remember how to do that on the calculator? All right, so what we need to do is we need to, since we're using tangent, we're going to do shift tangent. We have to do tangent -1 because we want the angle, okay? And so then we'll just do this 18 over, but divided by 24. And we can close that parenthesis down and say equals, and it's going to equal 36.86. 36.86. So let's call that 36.9 degrees. 36.9 degrees. Okay? And now we can figure out, so we know this is 90, right? So you could take that and subtract that. So you could do 90 minus 36.9. And you'd have to borrow over here, so borrow that down. And we'll get 10, and that's a 0.1, and that's 3, and that is 5. So this is going to be, B is going to equal 53.1, okay? So there's our two angles, and now we need our missing side. And again, we could use Pythagorean's theorem there, but we're trying to do it without using Pythagorean's theorem. We're just kind of going around the triangle to figure this thing out. So let me write these in. 36.9. So 36.9, and that was 53.1. 53.1. So now we're only missing one piece right here. Now, what I really don't want to do, and you really don't want to do this, is I don't really want to use a calculated value, which is kind of this, in order to find my hypotenuse. This lesson is on interpolation, so we're going to use some rounded values. We're going to kind of do a little bit of guesswork. So these are both rounded values. These don't equal these. These we had to round them off, so they're approximately equal. But what we can do, since we're interpolating, is we can find this side by, again, now we're going to use, here's what we have now. Check this out, and I'm going to show you basically a trig equation that is going to allow us to figure this out. So here's what we have. Again, let's use A, and we'll use 24 this time. So we'll use A is 36.9, and then what we need to find is we have the adjacent, okay? And we're looking for the hypotenuse. So what function uses adjacent and hypotenuse? Okay, that's right. The cosine is adjacent over hypotenuse. Okay, so here's what we want to do. We want to plug in what we know. We know what the angle is, and we know one of the sides. So let's plug in. The cosine of 36.9 equals this, the adjacent 24 over the hypotenuse, and we'll call that x because that's what we don't know. Okay? Now, how can we do this? How can we solve this out right here? We need to solve for x. In other words, we need to get x by itself. Now, this is going to take just a little bit. What we need to do here is multiply both sides by x. Okay? That side's going to cancel out. Again, we're trying to get x by itself. This is the best way to do it. Now we have x times the cosine of 36.9 equals 24. So now to get x by itself, we're going to divide both sides by the cosine of 36.9. That's going to cancel that right there, and we're going to end up with x equals this right here. And then we can go to the calculator to do that. So you just go to your calculator and you clear it out, and you say 24 divided by, we'll hit cosine first, and then 36.9. 36.9. Our calculator should handle this without any extra parentheses or anything. Let's hit equal, and we get 30. So x equals 30. In other words, our AB is 30. Now, these would be approximately 30, right? And this is going to be approximately 53. And this is going to be approximately 36.9, okay? So, but there's our values. There's our values of all of the different pieces of that triangle, and we never used Pythagorean's theorem. We interpolated, we kind of estimated, if you will. We rounded off some things, but we used trigonometry to solve it instead of using Pythagorean's theorem. And so there you go. You've got all the different pieces to this right there. That was 30. All right, well, that's all I have for you in this lesson, and that's all I have for you, period. All right, in geometry. We're done. So hopefully you come back and see me again next year for whatever you're taking. Algebra 2, love to have you back. If you're taking pre-calculus, we'd love to have you there as well. So work hard. Review that. If you missed something there, make sure you slide it back, watch it again, work on some of these. There's problems there on page 289 in your book. All right, thanks again for everything this year. I've appreciated having you watching these videos. That's all I got for you. Have a good one. Bye-bye.